Hello, today we're going to be talking about solid waste disposal. So we talked about different types of solid waste already in class today, and then now this is going along with chapter 23 in different ways we can handle that waste. So remember, in integrated waste management, our first priority is always to prevent the waste in the first place by reducing, recycling, reusing different products, or source reduction, preferably. And then after that, we have to find ways to deal with that waste. So we want to treat it in a way that is as sustainable as possible by composting, recycling, if that's applicable. But in many cases, we have to find a way to get rid of that waste. So this is kind of our last priority, but a lot of times this is what winds up happening to much of our solid waste. So there are a few ways we can deal with it. We can bury it, and most of our municipal solid waste is buried. There's two ways that they can be buried, either an open dump or a sanitary landfill. Open dumps are unsanitary, and in many cases they may harbor disease-carrying vectors such as rats and flies. Also, methane gas is being constantly released into the surrounding air as microorganisms start to decompose that solid waste, and fires often happen, and that can add to air pollution as well. Liquids in those open dumps are able to seep right through that solid waste and eventually find their way into the soil, and from there they could get into the surface water and the groundwater and cause some major problems. Hazardous materials might also be in there and contaminate the soil and groundwater. So our kind of more high-tech version of that dump is a sanitary landfill. And they make up about 54% of the solid waste that is generated in the U.S. winds up in these sanitary landfills. And they're different because now this solid waste is put into a hole and compacted and covered with thin layers of soil every single day. And this helps to reduce the number of rats and other types of pathogenic carriers that's associated with solid waste. It also lessens the danger of fire by it being underground, and it decreases the odor significantly. So the idea is, as long as these sanitary landfills are managed wisely, they should not pollute the local water sources, and you're using things like clay, because remember, clay does not really let water in at all. It just kind of soaks into that very first layer, but because it's such a small particle, there's no gaps for the water to get through. They also use plastic sheeting because the water's not going to be able to get through that either. So they line the landfill with that. In many cases, it might even be a double layer, a double liner, and then they use different systems to collect what we call leachate, which is any of the water that drips through that trash and might be contaminated at this point. So you can kind of see in our cross section of our landfill here, there's lots of different things that are at work to go into making this landfill run and sustainably. This picture might be a little bit easier to see, but you have this waste that is being buried. You have the liner that it's sitting in, so it is not just exposed to the soil or the water table. It is isolated on its own, and then you're covering it up every day, and you also have a system to deal with this leachate. For any water that does drip down through there, you are pumping that out, and you are going to take that leachate off to another area where it can be treated so that it does not wind up contaminating the groundwater. All right, now another term that kind of goes along with sanitary landfills is tipping fees. Anybody who's ever taken things to the dump knows that there is a charge to be able to drop trash off there. So that's the tipping fee. It's basically what they charge to be able to accept people's solid waste, and they charge that because it helps them offset the operating costs for the landfill, and it also allows that county or city or whatever area it is to charge lower property taxes, especially for those homes and businesses that are in close proximity to the landfill. And that tipping fee can vary quite a bit from state to state, county to county. Some jurisdictions can't handle all of the waste that they have, so they have to export their solid waste, and in that case that's going to change the amount of the tipping fee as well. So I want to draw your attention to these diagrams for a second and talk about basically how we're keeping all of this trash from contaminating anything else. So when you look at an active landfill, you're actually going to see many layers like this because remember they're covering it up every single day. So that forms these refuse cells that are covered by this daily cover of soil. About 6 inches gets added every single day, and this all gets compacted down. And then, as we said, the leachate can come from the rain falling on this trash, dripping down, collecting chemicals as it goes. So down at the bottom, they will have perforated pipes where there's little holes for the leachate to get into that pipe, and then they will pump it out of the landfill to an area that they can treat it, and it's going to basically be sort of a wastewater treatment system that goes through. In some cases, it's more advanced. And then there's two really important aspects to this landfill to keep it from contaminating anything. Your liner layers and also the cap that winds up going on it after your landfill is full. So those liner layers, if we take a look at them, again, I said there could be more than one of these layers altogether. There might be doubled up, but basically what it usually looks like is you have underneath your trash, you have a layer of soil directly underneath it, so that's going to allow water to drip through. Then you have gravel, which has those really big openings, so that's going to allow all that leachate to get into this leachate pipe and take it away. And then under that leachate area, you have a layer of clay because that's really, really fine particles stuck together. They are not going to let water through. So even if it gets down to this point, it's not going to go any further. And then underneath that clay is usually a plastic liner, or the plastic in many cases might be right above it, but in any case you have clay and plastic as two barriers there. And then it might even be doubled up in addition to that before you get down into your actual soil. Right, so that's again that chance to try to trap everything that might be coming through from that trash. And then after you've got your landfill full and you can't dump trash there anymore, they will construct a cap on the top, and this will also prevent contamination. So they do the same sort of thing with this cap. They have a tire chip layer because that's essentially rubber. It's not going to decompose, but it helps to kind of let everything drain and keep everything in there. Then you have a clay layer right on top of that to try to prevent water from getting in too much in the first place. And then your normal soil layer, your topsoil, and your vegetation on top of that. So when they're trying to decide an ideal location for a sanitary landfill, there's lots of different factors they need to take into account that might affect how the landfill works. Things like climate, rainfall, snowmelt, how likely it is to flood. You don't want to be in an area that floods a lot. Obviously, then your trash will wind up going downstream. You want to make sure that your soil drains well enough that you will be able to get it down to that leachate system. You won't get any pooling on top. You want to make sure that you're not too close to nearby bodies of water or wetlands that could be contaminated from the trash. And the trickiest part tends to be the social aspect. How do you get close enough to your population that's making all of this trash, but far enough away that they're not going to be upset by the smell, by the noise, and all the other things that go along with landfills. So it's an environmental justice issue because the landfills do tend to be built in those poor areas. Those people don't tend to have as much of a voice. But you can't put it too far out of the city because then that would cost you a lot of money in transportation as well to get that trash there. So we have lots of different problems that go along with these sanitary landfills, and one of them is the production of methane. So in the natural process of decomposition, microbes make this methane, especially when they're decomposing things anaerobically without oxygen. And then that methane can seep through the solid waste, and it can start to accumulate in these little pockets underground. It can even get into basements of nearby homes or buildings, and methane is very flammable, so that can be very dangerous. So conventionally what landfills have done is collected the methane and burned it off in a flare system. Now what we're starting to see is that a lot of landfills are starting to use that methane and burning it to actually make energy out of that and generate electricity for the plant. So that's a potential solution. So you can kind of see here how that might work. They collect the methane from that trash in these pipe systems, and then when they burn it off, they are collecting the energy from that. Now, it's important to note too, methane is also a greenhouse gas. So if it does get released, that is going to add to climate change. In addition, even if you burn it, you're producing CO2. That CO2 has to go somewhere, so that could add to climate change as well. Another problem is that even with the lining system, there's a good chance that some of that leachate is going to make it into your water supply. So for example, in New York, they had a Fresh Kills landfill, which was the largest in the US before it closed in 2002, and it continues to produce an estimated 1 million gallons of leachate every single day. So all that leachate's collecting hazardous chemicals from trash like heavy metals, pesticides, POPs, and these are getting into the groundwater if their lining system is not absolutely fail-safe, which is pretty impossible to make a lining that will never fail. And then another one of the biggest problems is just having enough space for all the landfills that you need. They're not an indefinite remedy. They fill up at some point. So from 1988 to 2009, the number of U.S. landfills in operation actually decreased quite a bit from 7,924 down to 1,908. So many of those landfills closed because they had reached their capacity. In some cases, they might have closed because they didn't meet a state or federal environmental standard, but in any case, you have fewer new ones being opened to replace the old ones. The new ones do tend to be larger and more complex, but it's still hard to open one, and you just do get to a point where you don't have enough space to dispose of all this trash. So sanitary landfills definitely have their advantages, their disadvantages. Some of those advantages, you don't get the odor because it's covered up, you don't have open burning, you can build it fairly quickly, it's essentially a lined hole in the ground, and it doesn't cost a ton of money to run compared to some of these other types of waste disposal. Later on, once that land is filled, you can use it for other purposes, although you still tend to have some leachate and methane problems with that. But we can see there's lots of disadvantages as well, and that's why a lot of people don't want these in their area. They would prefer to live far away from the landfill in many cases. So probably our next most popular way to deal with municipal solid waste is an incinerator, where they're burning the trash. And this is burned globally in over 1,000 waste to energy incinerators, so it's a somewhat more sustainable system in some cases because you're taking that trash and you're turning it into electricity. And there's a big one of these in Baltimore that does produce electricity for much of the city, and it does that by boiling water, which makes steam, and then they use that steam to power a turbine and get that electricity. So there are many countries throughout the world that do this for much of their solid waste. And in 2010, the US actually had 88 waste to energy incinerators that burned almost 12% of the MSW in the whole world. In 1970, that was less than 1%, so it has become much more popular. But basically, there's two positives here of incineration. First of all, you reduce your volume of solid waste by up to 90% because you're burning it. So then you have that ash that remains. It's much more compact and easier to get rid of at that point because you're dealing with so much less volume. The second benefit of incineration is that you produce a lot of heat to make this energy, and it can be a somewhat more sustainable system. So you can incinerate essentially most trash. And as I said, this is going to cut down on the volume of trash that you need to deal with in a landfill. So here's kind of how incinerators work: is they dump off this trash in a waste pit. A crane is going to move it into the furnace where it's going to burn. That heat from the furnace is going to power a boiler, which creates steam. The steam goes into a generator turbine in order to create some electricity, which will go out to the grid. Now, you're also going to get all kinds of contaminants here in that water because they've come up from those gases when it was burning, so they will also treat that leftover water with scrubbers to try to get a lot of the chemicals out. And then the ash that is left over will wind up usually in a conventional landfill. There's also going to be some ash that made it into the water itself, and that's called fly ash, and then that ash that had come out of the furnace kind of in the air is also going to be needed to be dealt with, but that tends to it can include some much more hazardous wastes. So that usually has to be treated a little bit differently. And of course, the downside to all of this is that in this burning process, we're producing lots of different gases like CO2. So those would go out in a smokestack. So as I mentioned, there is one of these that powers most of Baltimore City. So it's in the Westport neighborhood of Baltimore, and it's operated by Wheelabrator Technologies, which is a subsidiary of Waste Management Incorporated, or you've probably seen on the truck the big WM. And it's been in operation since 1985. You can see the smokestack with the big Baltimore on it every time you go down 95 or the Baltimore-Washington Parkway. It's right there where they kind of split. And it has been controversial since it went in because of the amount of air pollution it makes. And particularly because for several years it has been operating with an expired air pollution permit. It's also producing a lot of ash, which winds up going into the city's Quarantine Road landfill at Hawkins Point. So in 2010, several environmental groups, including the DC-based Environmental Integrity Project, or EIP, and the Baltimore Harbor Waterkeeper and the Chesapeake Climate Action Network and Clean Water Action Network, intervened, and they basically were able to stop the permit for this plant from being renewed, and that made the EPA basically say that they have to put these different pollution monitoring processes in place to try to reduce the amount of air pollution that's being produced there. Now there's also another incinerator controversy going on in Baltimore because they want to build a newer and bigger one, and the plans don't look much more environmentally friendly for that either. So this is again one of those environmental justice issues. And some of the problems with them, some of the reasons why people don't want these incinerators is, first of all, if you're burning it, you're losing those resources, you're losing those elements back to the atmosphere. So it's not part of the natural cycle. In many cases, you're also not recycling things that could have been removed. So you're really upsetting the balance. In addition, that air pollution comes with all sorts of toxic chemicals in it, like dioxins, furans, sulfur dioxide, which remember we said causes acid rain, hydrochloride, which will transform to hydrochloric acid in the atmosphere, heavy metals like cadmium, lead, mercury, which all biomagnify, nitrogen oxides, again a contributor to acid rain and smog, all sorts of particulate matter that can cause major respiratory distress, and carbon oxides, which add to climate change. Then in addition, incineration also liquefies a lot of materials that can wind up polluting water in different areas. So a lot of those similar materials can get into the water supply. So you can see kind of our pros and cons here. Again, we don't have one excellent way to deal with all of our solid waste. So in many cases, this may be a little bit more efficient than putting it in a landfill. And it's one of those things that we have to kind of weigh and come up with a solution. But incinerators and sanitary landfills tend to be the two major ways that we deal with this solid waste. Our other option for some of it is recycling, or for other parts we might be able to compost it. But we really don't at this point have any better methods. All right, let's move on now and talk specifically about hazardous or toxic waste. So hazardous waste accounts for about 1% of our total solid waste in the US, and it would include things like dangerously reactive, corrosive, ignitable, or toxic chemicals. Those chemicals could be solids, liquids, or gases, and you have to have some way to deal with these chemicals so that they don't get into the environment and cause all kinds of negative human health effects, as well as negative environmental effects. So you all have hazardous waste in your houses, and earlier in the year when we did our toxicity survey, had you go through and look at some of these things and some of their hazards to humans. So some of the things that you can do to try to reduce hazardous waste is not use as many of them in the first place, use less pesticides, try to use less harmful cleaners, such as liquid ammonia or vinegar or baking soda instead of the chemical cleaners. And the biggest thing is making sure too that these household wastes don't wind up in a landfill by just throwing them in the regular trash, making sure that you do pay attention to when the county has those household hazardous waste collection events, and then you can drop off all of those things that you might have left over, like paint, fertilizers, different chemicals like drain cleaners and things like that, and fluorescent lights, to make sure that these chemicals do not wind up causing water pollution or air pollution later on. So when we talk about hazardous waste management, again, the biggest goal is we want to produce less in the first place, so reduce our use. But then any hazardous waste we have produced, again, we want to try to recycle or reuse or somehow to detoxify that hazardous waste. And then our last priority, again, in our integrated waste management is to put it in some sort of storage to have a way to get rid of it. But again, that needs to try to be our last option. So we have two major laws governing hazardous waste, both of which you've already looked at when we talked about Superfund sites earlier this year. So the first one is the Resource Conservation and Recovery Act, or RCRA, which is 1976 and then amended in the 80s, and it instructed the EPA to identify which wastes were toxic or hazardous and give guidelines for how to handle them. And then in 1980, CERCLA came along, and this is the one that we call kind of the Superfund Act, and this established a program to clean up those abandoned and illegal hazardous waste sites across the U.S. and make sure that that hazardous waste didn't wind up in our groundwater. So when you're dealing with this hazardous waste, there's lots of different methods you can employ, but one of those that tends to be the most effective is bioremediation, where you take living organisms and you use them to get rid of that hazardous waste by converting it into something that is not as hazardous. So this could be bacteria, it could be plants, it could be fungi, or lots of different things that might be able to process this waste for you. So specifically, phytoremediation is using plants. In some cases, it might be a natural plant that's really good at taking up a certain toxin and it doesn't really harm the plant. In some cases, you may have genetically engineered that plant to be able to absorb it from the soil or from the groundwater. And basically, you're going to plant these organisms in an area, and they're going to start soaking up those toxins. Now, that does wind up in the body of the plant. So as I said, they're usually pretty able to withstand it, but you still have to think about what happens to that plant after you're done with it, after phytoremediation. So there is an example in Baltimore where they came in and they were using sunflowers to soak up some heavy metals, and there's a guy down there that does a lot of environmental justice work who was telling us a story that when he grew up, you would just go out into the field and pick the sunflower seeds and eat them. And they didn't find out until much later that those sunflowers actually had really high levels of heavy metals in them, so it wound up making a lot of people very sick. There are several different types of phytoremediation, or kind of steps to it in many cases. So once that plant takes up those heavy metals or whatever sort of contaminant, there are different things that can happen to them. So phytovolatilization is basically when they convert that metal into a volatile form, usually a gas, and they release that metal as a gas into the atmosphere. So that might be okay for some compounds, that's not good for others. It depends if it's an air pollutant. Phytodegradation, they are going to break down that heavy metal or other toxic substance within their tissues. So that's really kind of what we're after. We want to turn it into something else. Phytofiltration is that first step when it takes it up from the water, and then it goes into the phytodegradation process or into the phytovolatilization from there. Phytoextraction is whenever that metal tends to accumulate in little shoots coming off of the plant. Phytostabilization is going to limit the mobility, so that basically is how easily that metal can move in the soil. So the roots are helping to do that. And also the rhizospheres in your roots are helping to degrade and break down those metals as well. So all of these processes kind of work together to handle this toxic compound and get it to a point that it's hopefully not going to harm our environment anymore. So you can see some more examples of all of these things here. In certain plants, they're only going to do one or two of these processes. Like these sunflowers are doing some rhizofiltration, where those rhizomes are actually converting some of those radioactive compounds. And then some of these other types of plants, like the Indian mustard, they're breaking down that toxic metal, so that would be the phytodegradation. Right, so it depends on the plant, kind of what kind of contaminant it's going to be able to handle, and which of these processes it's going to do in order to handle that contaminant. So there's lots of advantages to using plants to do these things. Some of the disadvantages is that this does take a long time because you're dealing with a living organism. They can only take up so much at once. They can only grow so fast. And then, as I said, those plants can also become toxic to other things once they have those toxic compounds in them. But in general, it's always better whenever we can use a natural organism or a natural system in order to deal with pollution. Now, there are some other methods of dealing with pollution. You can incinerate it, and if air pollution is not a big concern with that type of compound, then that might be an option. You can also pass it through a plasma torch, which basically applies an electrical field and turns that gas into a plasma. And one of the disadvantages with that is it's really high cost to do that. It produces a lot of CO2, which is a greenhouse gas. It can also release chlorine gas, particulates, and it can vaporize and release toxic metals and radioactive elements. So it's not always the best option, but the advantages of a plasma torch are it's small scale, it's mobile, you can move it from place to place, and it's not in many cases going to produce any toxic ash. So it will produce the air pollution, but not the solid waste. Now, what tends to happen to a lot of our hazardous waste, because we don't have a great way to deal with it in large quantities, is it tends to be stored for long periods of time. So there's two ways they can do that. They can do it deep underground, called deep well disposal, which we'll talk about more in a second, or they can do it through a surface impoundment, which is some sort of pond or pit or lagoon where they store it at the surface. So deep well injection is when they literally inject it as deep underground as they can. So it's pumped down at a really high pressure into these porous rock layers, and they pump it down below the aquifer. So the idea is once it's down below the aquifer, hopefully it should not get into the aquifer at all and contaminate the groundwater. Of course, we know kind of how that works. We know that there are concerns like earthquakes that could shift all these layers. There could be leaks. It doesn't always work the way that they really intended it to. So the EPA does have an underground injection control program that is designed to try to prevent this water contamination as much as possible. So they use things like sumps, dry wells, and drain fields to try to keep that contamination from reaching the water, but you still have some contamination in some cases, especially, as I said, with things like earthquakes. So pause for a second here and kind of look at some of the trade-offs of these underground wells versus these surface impoundments. Then we also have secure hazardous waste landfills, and again, these are usually somewhat underground. So there are only 23 of these commercially in the US, but you can see there are a lot more sites that are storing nuclear fuels or high-level radioactive or hazardous wastes, and many of these are government sites. I want to draw your attention to this area right here for a moment in Washington. This is the Hannaford Nuclear Reservation, and this has a lot of history that goes along with. So at the moment, U.S. nuclear weapons facilities are no longer actively manufacturing nuclear weapons, but we still have a lot of nuclear waste to deal with. And every step in the production of a nuclear warhead generates a huge amount of radioactive and chemical waste. So if we look at this area of the Hannaford Nuclear Reservation on the Columbia River in Washington State, this was the main production site for plutonium that was used in nuclear weapons, and it's the largest, most seriously contaminated site in the U.S. nuclear weapons infrastructure. So it's a huge cleanup task. It's very daunting. You have tons of highly radioactive solid and liquid waste that were stored in trenches, pits, tanks, ponds, or underground cribs, and there's a total of 1,700 waste sites altogether. Just 2 concrete pools of water store more than 100,000 spent fuel rods. And these rods release radioactive uranium, plutonium, cesium, and strontium into the water nearby. So eventually the government is planning to relocate these materials to a place called YUCCA Mountain, which we'll talk about in a minute. But right now, it's already seeping all of this hazardous waste into the surrounding area. And there are tons of legal battles that are going on, that have been going on since the 1980s, because people are getting very sick as a result of all of this stored nuclear waste. This is just an estimate, and this is actually coming from the U.S. Department of Energy. You can see how it's kind of spreading out to the Columbia River, and once it gets into that water supply, it goes to everyone downstream of that. And you can see that even over a long period of time, you're not going to be able to completely clean it up. So that's one of the issues here. Now, I mentioned that we want to move this to Yucca Mountain. So this is a government project that has been under legislation for several years. They can't get this legislation passed to actually start building Yucca Mountain. There's a lot of economic and political things that complicate this. But basically, if you look at this, this is how much nuclear fuel we have just being stored in areas that are not very secure at the moment. So what they want to do is use this Yucca Mountain area, which is in this area of Nevada right here, and basically try to get all of this used nuclear fuel into one place that would be safe for it to be stored. But it's extremely expensive to build this. They'd literally have to kind of hollow out that mountain to have an area for it. There are a lot of things that suggest that it could work, but then again, we're also dealing with, plate movement and everything else, just like in any other area. So there's a lot of controversy. A lot of people think that this might not be a safe way to deal with it, but we don't have a better way at the same time. One of the other issues with this is all that hazardous waste would have to travel in order to get there in the first place. So how do you transport that? Is it being transported along the rail routes? Is it being transported by trucks? Is that going to contaminate people along the way, or contaminate our resources along the way while it gets there? So when we're thinking about Yucca Mountain and whether or not it's a good idea, one of the things that we always want to keep in mind are some of the past environmental disasters. So one of the ones with hazardous waste that you should be aware of is the Love Canal. In 1997 in Niagara Falls, New York, basically what happened is this chemical waste, hazardous waste, had been dumped for so long, and schools and houses had been built on top of that. And then in the 70s, this contaminated soil started oozing up from underground, and children were playing in this soil. There were schools built right on top of the soil, so it made many, many people sick, especially those young children, and in many cases caused lots of deaths. So this was really what spurred the development of CERCLA and the Superfund Act in the first place, because you had all of these different diseases coming about, many of them cancers, that were caused by this hazardous waste. So we always want to try to think about, how do we avoid situations like the Love Canal? How do we make sure that does not happen with Yucca Mountain? And how do we achieve that low waste society where we're not going to make all of this hazardous waste in the first place, or all of this solid waste at all? So these are some of the things that we really need to keep in mind, especially this idea that everything is connected. Our trash does not just go away once we produce it. We have to find a way to deal with it, and not just by diluting it, because that means it's still out there somewhere, but a permanent solution that is not going to allow us to keep polluting our environment. And at this point, nearly every person on Earth has detectable levels of POPs in their blood. Remember, those are those organic pollutants that are insoluble in water. They're soluble in fat. They start to build up in your body. So if we want to achieve our best health for our citizens, we need to find a way to have a low waste society and deal effectively with the waste that we have. All right, so come in with these to be checked next time, and I will see you then.